OK, so title of this presentation is Build Alien with Akka Cluster, because I have Akka Cluster here, running on Raspberry Pis and on my laptop. And basically, we are defending Earth from alien invasion. OK. So agenda, short introduction about Akka Cluster. Who knows what is Akka Cluster? OK, so almost everyone. Then going to live demo, and then we'll be killing or disconnecting JVMs and testing if application is resilient and self-healing. OK, so this is my cluster, if you are not able to see it. I have 3 Raspberry Pis here. And as you can see, they have icons, the magnet, ruby, and diamond. This is important because we'll be able to match what is on the screen with piece of hardware. And a few words about me. I'm working for Ocado Technology, company which is building online supermarkets and automated warehouses. We are based mainly in UK, but we have offices in Poland. I'm working in Poland, in Bulgaria, and also in Spain. OK, so we're going to skip this slide because we don't have much time. It's about the knowledge. So it's like iceberg. If you're reading blogs, you're going to just scratch the surface. You learn only 20% of something, or 10%. If you want to learn more, you have to play with technology. You need to do some stuff. And you need to fail on production. Yes, you need to learn what you have done wrong. And then you're going to fail again. And if you are not fired, you will fail again and learn again. OK? It's a normal process. OK, so what is Akka? Based on Akka documentation, the toolkit to build resilient message-driven application on JVM. And I'm using Akka here. I assume that everyone knows what is Akka and have used it. OK. Actor model. OK, I'm going to skip some slides. Persistent actor. You know, actor can recover from failure on another machine or can be restarted, migrated. And we are using persistent storage, some external storage database. I'm using Cassandra one-node cluster on my laptop. Very simple, but efficient for this presentation. OK, Akka cluster, it's supposed to be fault-tolerant and have automatic failure detection. And we are going to check this on this presentation. Sharding. Are you familiar with sharding? OK, so basically sharding works in this way, that you are sending message to actor and you don't care about physical location. Sharding distribute actors on some nodes. You don't know which one exactly. You just send message, for example, message A to actor A, to sharding coordinator. And it takes ID of this actor based on message. You just provide some function. So message A for actor A, and forward it. You don't care about physical location. You don't care on which node this actor is running. And that's why I have these icons on Raspberry Pi and on a screen, so we can match it. And the same with message to actor C and message to actor B. OK. Cluster singleton. It's a similar thing like a sharding, but you have only one instance of specific actor. It sounds like bottleneck, and we'll see how it behaves if you killed sharding in a cluster, or you killed actor, which is run as a singleton, as a cluster singleton actor. OK, it's a similar thing, so it runs in a cluster only once. You don't care about physical location. You just have ID of this singleton. OK, and this application, Reactive Missile Defend, I have created this for fun after some training, advanced Akka training. So it helps me to visualize what is going on in an Akka cluster in terms of failures. And my cluster is, so I have 3 Raspberry Pis, and I have 2 nodes running on my Mac. It's a command line GUI and GUI in a swing, which is running also game engine. And I have a Cassandra as a persistence. So basic message flow. There's a game engine. And this game engine is sending message to towers, defense towers. You can see this tower. OK, you can see many defense towers. And game engine is sending message to these defense towers about what is situation, about enemy missiles, bombs, and send the same message also to status keeper, which is responsible to get all the data so it can be represented on UI. And defense tower is reacting. OK, I want to fire a rocket. Just inform game engine about it. And also sending its state to status keeper, just like ping. So I know that this defense tower is not responding for a few seconds, just for visualization. And GUI is just asking status keeper actor about state, give me actual state, what do you know, and render on a screen. Architecture is very simple. OK, you can skip it. OK, so live demo. Let me start game again. OK, we have cities, like in missile defense. We have defense towers. Computers is trying to defend our cities. And as you can see, we have icons below defense towers. Like there's a diamond, and we have a diamond here. So it means that this defense tower is running on this piece of hardware. And what else do we have here? We have list of Raspberry Pis. Green, it means that it's OK. Orange, it means, OK, this node is unreachable from cluster perspective. And red, it's dropped. And we have also information how many defense tower actors are running on this node. So if I highlight this Raspberry Pi, I can see towers running on this piece of hardware. And one more thing, towers are persistent actors. So as you can see, this defense tower is on level 4 because it's learning how to intercept enemy missiles and have angle error 20%. And experience is also expressed as these blue lines below defense tower. So the fatter is, the more experience. So this is on level 4 with this range. And this defense tower is on level 1, range is lower. OK, so we can move on. So this is one of our nodes, yes? As you can see, it works perfectly. Network is stable. Power is stable, yes? So this is a network cable. You don't expect that something happened in your data center, yes? But if lady is cleaning and just hit something, it happens, yes? So what happened? As you can see, defense tower now are red because I'm not receiving status updates from this defense tower. And this node was orange and now is red because it was dropped right now. And sharding thinks, OK, I have actors running on diamond, for example, this, but diamond is dropped. So now Akka should migrate these actors to different nodes. OK, it's done. And it's blinking how many messages were lost, because there is no delivery guarantee. Okay? We are always expecting that it will be delivered, but sometimes it's not. OK, so this was dropped because of network issue. But this node can have problems with, for example, power, yes? It happens. And situation is the same, OK? As you can see, this node is orange. So cluster knows that something is wrong. And you can see defense tower are showing counter, how long we don't have update. And as you can see, this is a level of this defense tower. It should be the same after recovery. You have to wait a few more seconds. I know how many, it depends on a cluster. It's internal Akka thing. You can tune it. OK, let's give it a few seconds. maybe a few more. As you can see, cluster can be working in a different way that you are expecting. Yeah? You are expecting that it's fault tolerant, it works, but as you can see, with some delay. Okay, I think I have overloaded this small Raspberry Pi. Let me connect again the power to magnet. It should reboot and start. And I will connect again diamond. What do you think? Will it recover? Will it connect quickly to the cluster after just reconnecting network? Maybe? The same? No, it will not connect. Okay? Oh, it will not connect because Akka will do not allow you, Akka cluster, to connect again. If you are dropped from a cluster, you are dead to it. Because it's a situation called split brain. I have defense tower run here. I have the same defense tower run now on Ruby.
But you could have had a quorum with the other two at the time that you first
Okay, so it works like this is persistent actor, yeah, and I didn't kill this actor. I just disconnected network. But from cluster perspective, this actor is missing in action. So after specified time, it will recover this actor on different node from last known state. But this actor has now two separate lives. Yes? So this is a complicated situation. There is split brain resolver to do something with it. But we are not using it, so I'm not the expert, and I don't believe in this solution that it will be automatic. You need to provide something, how to recover from this kind of situation. Okay, we have very limited time. Let me start again. Okay. So diamond is not connected again. I will just restart it with removing power. As you can see, Akka has some issues right now about how to distribute actors. Maybe it will recover. It should recover from it. But what else we can run? As I said, we have a cluster singleton in this cluster. This is actor which is getting all information about situation state, and it used to render UI. So I can kill this actor, yes? This is cluster singleton. And what's now? We are asking this actor, what is the state of game right now? And no answer. So in a sharding, if one node is killed, in this example, 1/3 of customer will lose functionality or will lose 1/3 of customer for short time. But if you killed a singleton, you will lose this functionality for all customers. Yes. Okay, now it's recovered. Okay, now it's back down. Okay. Sometimes it's surprising. Okay. How much time we have? 20 minutes. Plenty then. Okay. I have a list of things what we can do with it, but we don't go with all points. This project is on GitHub, so you can experiment with it. So what else you can do? You can kill Cassandra, for example, kill persistence, and observe what will happen. So basically, for example, sharding will collapse because it will know it depends on persistence. You can configure sharding to use distributed data, of course. So, but in my example, I'm using Cassandra as a persistence for sharding. Okay, and you can restart, for example, with Cassandra and check how long this application needs to recover from it, because you have some mechanisms to fail fast in case of failures. So it's what we can do. We can overload Akka cluster and look how messages are not delivered in time. And
so can I ask a question?
yes.
So when you have these 3 Raspberry Pis, say, like over the course of the life of this program, which is supposed to run forever,
Hmm?
these things are going to go up and down.
Yes.
Something's going to happen,
Hmm?
right?
Yes.
And so you're saying that the program will never run forever. It'll sort of die at some point, right?
This
Does-
program?
Well, if like, say this is running for like 3 years and
Hmm.
you're putting too much power to your Raspberry Pis,
Yes.
they heat up, they burn out,
Yes, it can die, and you can replace it with another one.
but but you have to restart things, or so you say. I mean, you said when you disconnect it, it's considered dead from that point, right?
Yes. This instance of actor system is considered as a dead for Akka cluster. It doesn't think, okay, this is IP. No, it's if actor system is created, it will generate some random UID as ID of this instance, and this instance of actor system will not be able to connect to the cluster again.
Yeah, so basically there are many different things you can do, but one of the things is one of those actor systems which are now competing to be one of them can be restarted. Like, the instance inside the JVM can be restarted and then rejoin the cluster, and the situation is resolved. But it cannot be done manually, automatically. You need some manual steps. You need to have some kind of algorithm based on your business logic in order to achieve this situation. So that's why it's so difficult.
So is it the situation where you pull the network where it can't rejoin, but if you pull the power, it can rejoin?
Because it's just a restart. It's
If you
a actor system
So
that
it's a
joins.
new actor system,
Yeah.
and then there's a seed node that always looks for.
From cluster perspective, it's a new node joining.
Yeah.
New.
So it's only
But IP
but-
is it's the same in our example.
And this is because when you pulled out the network, the other nodes your algorithm is such that the other nodes have decided to eject the unresponsive node.
Okay, so question is how it is decided. So I have slide about it. Exactly. So we can go to it. So what is going on if something goes wrong? This is example with some data taken from one of recording. So basically, at the beginning, time 0, oh, yeah, too much. Something goes wrong. Network disconnected, or power down, or JVM just were killed. For a few seconds, we are not aware that something goes wrong. And cluster nodes, actor system, are gossiping with each other. Have you heard something about Mike? Have you heard something? And no response. OK, we assume this node is missing in action. Yes, it's not unreachable. And this time is specified in your actor system configuration. So in this example, it's something like 20 seconds. So cluster knows, OK, this node is unreachable. Now I'm counting to 20. And if this node is not coming back, I will drop it at this point. And decision was made. Actor system was dropped. Now I have to recreate actors which were run on this node, on another one. So it's recreating them for a few seconds. And then situation is back to normal, operating like it was fine. No issues. OK.
What if you have to do it like a rolling restart? Is there a way to tell it, I am leaving, and then what's the length of time that it takes?
OK, rolling restarts. OK, there is a case when you can say, OK, I'm leaving. And I have tried to do this, and I don't think that I have done this perfectly good, but we can try. OK, let's give it a few seconds so actors distribute themselves on all nodes. For example, this, Rabi. Let's call leave cluster method. And when I do this,
What does it do in this method?
it will call cluster leave. As you can see, it worked very quickly. Some of messages were dropped. I don't know if I'm doing this correctly, because cluster is now unreachable and will be dropped. So I'm doing something wrong, because I expect if I exit cluster, it should work instantly. And without this application, I will do not learn about this, because who looks on logs on production just without issues? Okay.
So are you persisting the events stream to this unread?
Yes, question is if I'm persisting events.
Right, so in order to recover,
Yes, these actors, towers, are persistent actors. And I'm persisting events like, okay, you gain some experience, last message ID, stuff like this. And I'm able to recreate actor with the same state. And because I'm also saving last message ID, this is an incremental number, so it's easy to count how many messages were lost. Okay. Okay, and this result depends on your cluster configuration. In my example, I have used something called Autodownlink time. It means that after specified seconds, minutes, node will be dropped. But you can say, OK, I don't want to do this automatically. So let me summarize. Failure detection. OK, it works. It needs some delay. You can lose some of messages. And if you want to tune it, you can make it more sensitive, but you can get some false positives. When I was running similar example after training on localhost or running this application only on localhost, I can tune very aggressively this setting. So it works very quickly. But if I move to network environment, I get a lot of more false positive, and application was not usable. So you have to remember about this trade-off. OK, so failover scenario, how it looks. Cluster nodes are start to losing heartbeats. They're gossiping each other about, have you seen this node? And if you miss some of messages, you can configure it, how many, and how sensitive this mechanism is. Nodes become unreachable. After specified amount of time, node is removed from the cluster. You can also do this manually. And then sharding can recreate actors on different nodes. And for Singleton, the same. So what we have learned, so reading documentation is not enough. You should play with your applications. On production is the best because this is the same environment. You will not recreate this on localhost. OK, thanks you guys. If you have any question, I will be here also.
Oh, thank you, Krzysztof.